So if we calculate that we have 11.25 watt-hours theoretically as energy inside these three together. And then we measured the maximum self-discharge for a period of 2 weeks, and that was 2.8 watt-hour. Thus, the minimum total usable energy for that period is then at least 8.35 watt-hours. And if you're using the conventional batteries, you will never know exactly the total usable energy that you can get from the system, but with ultracaps you will always have these 8.35 watt-hours, regardless of the temperature and other factors. So, using the figures from the previous pages and calculating the flash character duty cycle of 12.5%, we end up with 14 days autonomy. And that has also been verified in tests. So what we have here is a working solution, and the question is, so what are we waiting for? Why don't start making these at once? There's still some drawbacks we have here. Two major ones. They are still expensive compared to lead-acid batteries. And the other one, the low energy density means that it requires a much bigger space for the battery. And also minor things which would be the high self-discharge means that you have to always charge them if they have been in storage for a longer period of time. And in some very extreme places in the world, the 85 Celsius degrees maximum, absolute maximum rate may be an issue. Not in Finland though. But, so what would we gain in using these ultracaps? Logistics. They can be stored empty. They will not fail nor degrade if they are storing for a very long time. And even if they require charging after storage, this can be done in less than a minute with an external charger. And the lifetime, very long lifetime, easily more than 10 years without any significant degradation. And a very high charging efficiency means everything from the solar panel will actually end up in the ultracap. It's also very easy to measure the state of charge in a capacitor. Since the energy stored in a capacitor is only a function of the capacitance and the voltage, and when the capacitance is constant, a simple open circuit voltage measurement defines the state of charge. These lanterns would be totally maintenance free, and there is no heavy metal included in these ultracaps. And I spoke much faster than I thought because I'm finished. Thank you very much.
Thank you, Jonas. We now have 10 minutes for questions. So, is there anyone who would like to clarify or expand on what has been said? I don't see any hands at the moment. Perhaps, I do see one person there.
Dimitri Rostovshin from Transos. I have a question to Dr. Bart. Can you say, during your experiment, did you make any tries with vessel search and rescue radar transponders not with Raycons, because it's also very important with how it's compatible with new technology radars.
Testing an S-band NT radar, but of course there are X-band NT radars on the market, not for SOLAS vessels, but that would also be an interesting test if we get our hands on one of those.
Thank you, Nick. Does anyone else have a question? One thought that occurred to me, if I may take advantage of my position here, is a question for the radar manufacturers. We've heard the results of Nick's experiments with Raycons. Is there any possibility of including perhaps a short high power pulse or some other way of triggering the current Raycons without having to modify them or improve their performance in any way? Would either of you like to comment on this point?
I can answer both. Yes, we can. What cost? That's the problem. Of course, in that case, we have to add a magnetron to our solid-state radar. So, is it the right way?
Basically, I agree that it's the question of course, because of course you can always add something on the back of such a radar here. I think it will overall be less expensive to make Raycons being able to handle and to accept, let's say, the long signals here, integrate them and then respond to increase the sensitivity of the Raycons, and also to make a much better balance between the sensitivity and the transmission, because there's really a big unbalance as it is today. We did not finish our test of Raycons, but our at least calculations is that we can meet the IMO requirements, but just meet them. So, and the test will show how it works.
Thank you. Does anyone else have a question? Oh, yes.
Marek Leduchowski, Maritime Office, Gdynia, Poland. I would like to ask about these radars, if they are in production already available. Thank you.
Can you repeat the question?
Thermal radars.
Thermal radars.
Yes.
Thank you.
Yes, we started production in January. We expect to have the first wave for customer installations after the summer holidays.
Thank you, Jens. Any other questions? I do not see any. Going once, going twice. But in that case, I think we have almost reached the time for coffee break. So this session on emerging technologies continues after the coffee break. The speakers who are here will be available at the end of the next speaking period. So if you think of any question in the meantime, please make a note of it, and you can ask it then. My thanks to our speakers for an excellent job and impressive timekeeping. Please join me in expressing our thanks in the usual way.